So we're gonna look at simple interest, and then later on we'll talk about compound interest. Right? If we have a little more time, I think we're going to go over to a whole new topic. So let's start with this simple interest. A lot of times, people well, interest as a whole, right, is connected with people lending money. Right? You lend money, you can't just lend people your money and they do what they want with it. And let's say you give them $1 million, they give you back $1 million, right? That doesn't make sense. Uh, you want some interest in it, right? If you're a business person. Let's say some maybe your friend or family and you lend them $1 million, right? What you gotta understand is money goes down in value as time go by, always, all over the world. And as time go by, money loses its value. That's a fundamental truth, right? In Guyana here, only the other day, I was watching a YouTube video that a guy was talking about time when the Guyana dollar was $2 to $1 US. You believe that? It still is in a lot of the Caribbean countries, like I know Barbados. I do some work with CXC, and they pay me in Bajan dollars, And the exchange, when I checked it, it's really $2, two Bajan dollars for $1 US. So they have a very strong currency, right, in that country. Guyana currency used to be that years ago. I cannot remember when it was $2. I remember when it was $4. Then it jumped to 10, and then it jumped to 100, and well, look where it is now. It's about 210 maybe for one US dollar, right? The US dollars remain, it has devalued too, it has lost its value to some extent too, but at a much slower rate, right? At a much slower rate than the rest of the world. The Guyana money, I think this word is spelled around interest. Yeah. Anyway, the point what I wanted to make is that money loses value. So if somebody lends you, all right, or if you lend somebody $1 million, and let's say that's 2024, and in 2025 or let me say 2026, they give you back $1 million. This 1 million in 2024, what it will buy now, let's say it can buy, this can't buy nothing much here. That's what I can't think of it. Let's say you can buy one of the lands, that the government selling out. I think they sell out land for $1 million. One house land, right? House land. In 2026, it will not be able to buy a house land, right? It might not. You can't buy a house lot in 2026 with $1 million because the house lot might now be 1.5, right? So you lend $1 million that could buy a house lot. And the people, let me say they give you back your money. You say, man, I give you back $1 million in 2026. And they might give you peace, and you don't even see the money. It can't buy one house lot, right? So you will lose. You got now a house lot is $1.5 million, right? So it would have made sense if you take it instead of lending it to some relative or friend, right? Unless you're some Christian person and this person really needs this money and whatnot. So I'm not talking about that, right? And you lend them, instead of lending them this money, you just buy a house lot. And in 2026, you sell that house lot probably for 2 million or 3 million. You triple your money. You understand? You always have to sell at a higher rate, right? than the way you call rate of inflation. I don't know if you understand all of that, right? So if in 2026 the house lot is now 1.5 million, as I said, right? You won't sell for this and all. You want to sell at maybe 2 million, 2.5, 3 million to make a profit, right? So when you lend your money, you lend out your $1 million. You want to ensure that they pay you interest, because when they give you back your $1 million, it's not going to have the same worth as this. And that's why there's this thing called interest, right? Interest rates rule the world. I mean, the financial world. Interest rates is of paramount importance. And that's why you want to learn about interest, because some of you will indeed study business to a higher level. You might become managers, you might become, you might run a business of your own. You'll have to borrow, lend money, sell things. Interest is of paramount importance, right? And we'll start with something called simple interest. And you'll see why we call it simple, right? And you see simple interest being used a lot in simple interest. It's used a lot in like people lending you stuff for a short term, like lending you money. Like when you go and buy things from like Coats, hire purchase, the outstanding balance that you owe them when you pay for an item and you buy it on hire purchase, let's say you pay a certain deposit or you don't deposit anything at all. Whatever you owe them, very often they do the calculation and they attach an interest. They don't compound the interest, right? I've bought a few things from them. I've never bought anything on hire purchase from them. I did buy something from another enterprise, a guy by the name of AIE and Sons in Morbisi. And I noticed that they attached a 20% interest to what I owed them. I noticed that. Right? And I calculated, I said, oh, they seem to be working with a 20% interest. Right? Some of the banks and so on. When we come to banks don't really use simple interest. They do something else. Right? The compound interest thing. But yeah, you find when you buy things like from Courts, you buy from these other places that sell higher purchase and so often they use simple interest to calculate how much extra you have to pay them, right? So how do you calculate simple interest? There's a nice formula, simple interest equal to, there's a formula, I'll write it here, what am I doing? PTR over 100. Right? PTR over 100. They have various ways they put these in the textbook. When you read carefully, you have different ways. I'm only going to use this form, right? Because I've seen textbook where they write, like here, I remember it like Peter, Peter, Peter over 100, right? Just to help you remember it. You have an open book test, so I worry nothing about remembering nothing. Some people have PRT over 100, right? Port over 100. What does this P mean and so? So simple interest. Yes, I mean simple interest. The P is what we call it principal. Principal. This is how much you lend or borrow, right? Time. T is time. Right? Usually in years. Right? And the R is what we call the rate of interest. Right? It's usually a percent. That's it, right? So you can use this formula. Uh, take it in a little later. So if you, let's say, all right, you want to lend some money or you borrow some money. And you know, some of these money lenders, they aren't very bright and so um, they might want to get into the complication of compound interest. So they say, man, they could just use a simple interest approach, you know. But let's say somebody lends you some money and um, let me just cook up one, right? A money lender, money lender lends $1 million. Oh, y'all hear of something called loan sharks? You ever heard that? You ever heard that term, loan sharks?
No, sir.
You're saying yes?
Yes, sir.
Never fall into the hands of one of them because they charge enormous amount of interest, right? And usually they're doing something underhanded, illegal, right? No, most of the time it's that. So they lend you $1 million, maybe want a large interest. They'll say, all right, every month they want 10%, right? They tell you that kind of thing, which is that's an exorbitant amount of interest, right? So let me go with our little formula here, right? Lens that at a, let's say 20% per annum interest rate. Interest rate. If the borrower has to pay back this amount in, let me go in 6 months. How much does he have to repay in interest, right? Well, no, I'm saying this wrong. How much do you have to pay? Let me say overall. And how much interest does he pay? Right? But here's the situation. Person lends the borrower $1 million. Interest rate is 20% per annum. Right? And they have to pay back this money in 6 months. So how much money will they pay overall and how much interest will be? And even though the question is phrased this way, you have to calculate the interest for us, right? So it's simple interest, right? Simple interest. So simple interest is okay. We just set it PTR over 100, which will be what's the principal? $1 million times the time. Time here is 6 months is how much years? I didn't calculate.
It's half of a year, sir.
Good. Calculate this to me.
Sir, 100,000.
So that's the interest, right? Total to be repaid the 1 million plus the interest, right? So they'll have to pay back 1,100,000. Right? That's the interest. And sometimes the person might not tell you to pay all right away. They'll say you have the entire 6 months. So every 2 months you can give them something. But they don't care that you actually pay them after 2 months some amount of money. They don't take that out of the principal. They calculate for the whole 6 months. That's the downside of simple interest. Everybody follow this example?
Yes, sir.
Yes, sir.
Good. Now we have this formula. Simple interest equal PTR over 100. But remember, we did this thing called transposition because there are times when we might know the simple interest, right? We might know some other things, and maybe we want to find the principal, or we want to find the time, we want to find the rate, right? So how do we find it? Can you do it in your book and see if you can rearrange to make P the subject, T the subject, R the subject, and see if you get this. So P is going to be equal to 100 times the simple interest over TR. Similarly, T is going to be equal to 100 times the simple interest over PR. And R is going to be equal to 100 times the simple interest over PT. So it depends on what the question asks. If maybe they give you the other information and they want to know, tell you, they want to know P, they want to know T, they want to know R. And these are additional formulas to help you get that, right? And the notes I sent you, they have lots of examples with that. More often than not, like the example we did, that's what we'll be exposed to most of the time. Where, I mean, in reality, you actually want to calculate how much interest you got to pay, and overall how much money you got to pay. In all, take so much from you, how much I got to pay you overall, right? So you calculate the interest and you add it to what you borrowed, and you will know how much you got to pay overall, right? So the total you would have to pay, total will be equal to, well, whether you actually repay, right? Total repayment will be the simple interest plus the principal, right? Principal is how much you borrow. This is something that you use in everyday life. But as I told you, one time I bought something from a famous business, a well-known business in my area. And what happened is that I just want to know how much they're charging, how much interest. So I looked at how much, well, the thing I had to make a down payment. I think it was a fridge, and I brought the fridge home. And I looked at how much I owed them and how much they're asking me to pay. And I said, oh, now I can, and I calculated the simple interest that they were charging. And I noticed that they were charging a 20% simple interest per year. Sometimes they don't do it like that. Sometimes, as I said, you know those loan sharks type of people, right? Sometimes they charge per month. They don't charge interest per year. You know, all loan sharks for years. They want it back per month. And they might say, look, I want 50% more every month, right? Or they want, you know, they charge an enormous amount per month. Very often they have people that will come and threaten you and harass you and so on. Gotta pay or else you're in danger. Never fall into their hands. Well, I'm talking so freely and recording. I hope none of you all in the class, somebody in the family is a loan shark. There was this sort talking about loan sharks. Go get him. Good. So let's turn our attention now to the matter of compound interest. Compound interest. Now, the business world, especially the banking world, banks, they deal with compound interest. When they lend you money, they compound the interest that you owe them. When you borrow money, when you invest money in a bank, you know, it puts money in a saving account. You also earn interest through compounding, they call it, right? So let me just explain the principle behind this whole compounding thing. Let's say, all right, you put in $1 million, right? So you invest $1 million, right? At the beginning of the year, right? So 1 year passed, and let's say this bank is offering, let's just say the bank is offering the interest rate is, well, banks offer very little, right? Like the bank I'm with, Scotiabank, I think they give you 1% per annum, right? I'm not going to go with a lot of banks don't compound every year. They compound quarterly and so, right? But I'm going to go with, okay, 1% per annum. So at the end of first year or 1 year, the amount of money you have would be the 1 million plus 1% of a million, 1%, which is 1% times. Can somebody do this to me? 1% will be what? 10,000. So at the end of the first year, the amount that you accumulate or accrue, you hear this word, the amount that accrue is going to be $1,010,000, right? Because you earn how much? 10,000, right? Anybody doing the calculation? The interest.
Yes, sir. 10,000, correct.
Yes, the interest would be this amount. So at the end of the 1 year, you actually have now $1,010,000. Let's say you don't trouble it, you leave it there. You leave it there. In the second year now, at end of second year, what happens? So initially you had $1,010,000. You will now earn another 1%, which is 1/100 times the 1,010,000. Notice you're not using 1 million here, because at the beginning of the second year, you actually have 1,010,000. So you will now have, okay, this 1,010,000 plus, what's 1% of this now? Strike off 200, I'll get that.
$1,020,000. When you work out the top one.
No. 1% of the 1,010,000. How much is that? Is that it? 10,100? Is that right? Huh? Striking off 2 zeros. You get 101, 210, 10,100. So when you add these two up, you get what? 1,020,100. Is that right?
Yes, sir.
Yeah. You see? That's compounding. Right? In the second year, your principal is no longer 1 million because you actually had interest added on there, right? In simple interest, the principal remains the same. In compound interest, no. Your principal at the beginning of each year is going to be greater because the interest from the previous year is being added on and carried forward. And the calculation of the interest as well is on that new principal. See, so that's it. That's the principle behind compound interest, right? So if you invest some money and your money is growing according to compound interest, or the bank is offering compound interest, right? You're not going to use one fixed amount in the calculation of the interest. No, as you can see here. To simplify things, there's a nice formula. And this formula does not tell you the compound interest rate. What it tells you is the amount that would accrue, right? The amount that, they use the word ACCRUE, that's the word. Accrue means accumulate. How much accumulating after so much time? This formula is this. P, which is the principal, times 1 plus R to the, well, you can put N here or you can put R. Let me put N here. Right? So here, A is the amount that will accrue, right? Or accumulate, right? This is a U here, accumulate. P is the principal, how much you put in at the beginning, right? Initial investment, right? R is the rate of interest, right? And I will, in this case here, I'm not going to call it a percent, right? Okay. 1% interest will be equal to, or R for, okay, so for 1% interest, R equals 0.01, right? That's what you'll put there. Some textbooks will actually have a formula where, okay, instead of this, they'll put this P into 1 plus R over 100 to the, and they'll use T here, right? This R is really the value in percent already, right? They'll put the percent there. That's why you put 100 here. I'm not putting the 100. So the R is the actual when you don't divide by 100 and so, right? And N N is the number of compounding period, right? It's not always years. It's not always years. I'll show you that just now, right? I'll show you that just now. So that's our formula here, right? So let's take an example. Got a good look at the formula? So let's move it. So if a person invests, let's say, let me use the million again. I seem to like that number. In a bank that offers, say 3%. What am I doing? 3% per annum. Let's go per annum, right? Okay. What am I doing? How much will accumulate after 3 years? All right, let's just see that. So, no, I mean, that calculation I was showing you as to how compound interest works. To do that process for 3 years, and especially if I put 5 years there, that is going to take you very long, right? So what we do is use the formula. So we use A equal, remember that formula, P plus R to the N, right? So that would be what? 1 million bracket 1 plus, well, 3% will be 0.03 to the third power, right? It becomes, if you go over here, let me move, all right, it should fit here. It should be what? 1 million times 1.03 to the third power. Anybody can do this in a calculator. Take 1.03, raise it to the third power, and then multiply by a million and tell me what you do.
Sir, 1,092,727.
Great. 1,092,727. Right there. That's it. Right? So you actually can calculate it like that. Everybody follow this?
Yes, sir.
Right. So we see how to use this formula here, right? See how to use this formula. However, in the real world, banks don't really pay people at the end of each year. No, they don't do it so. Like if you invest money, no, they don't do it so. They actually compound, like both banks I'm at. they compound quarterly. So there's another formula, right? It's the same formula really, but I'll kind of what should I say? Let me modify the formula.
Sir, before we move forward, right, just to clarify, the 0.03, is it, yes, I know we get the 3% per annum on the 3 years, right? So based on the formula, how does the
This is in
zero,
years. How many years? Right?
yeah,
I should have used a different number here, right? But
okay,
you're confusing this tree with this tree. No, this tree, 3% is 0.03.
okay,
Yeah, I should have used 3 years. I should have used 4.
okay,
You can see the difference. Yeah,
okay,
that 3% is 0.03. That's what we put here.
okay, sir.
Years is what we put here. Yeah, good thing you raised that because yeah, bad choice of numbers on my part. Yeah, as I was saying, so sometimes banks would they might not um they might not be compounding every year. They might compound every quarterly, right? So what happens now, right? What happens now is that your R and your N has to be modified. So what happens now? All right, let me take an example. So a person invests, all right, we go $1 million again in a bank that offers, and let me go the same 3%. Let me use some different figures because let me go with a 4% per annum. Right? And when we talk about bank here, we mean they're doing it compound interest, right? Compounded every quarter, right? Meaning every 3 months they'll compound the interest. How much will accumulate after let me go with 5 years, so different numbers, right? So we're going to use the same formula. We got A equal P 1 plus R to the N. Now we got to know now, okay. P in this case, P, say 1 million. Our R now, our R is not going to be 4, right? It's going to be, and your R now is really the, what did I say? Just give me a second. Let me scroll back and see what I said R is. Yeah. See, I said rate of interest, right? And the rate of interest now, they have the annual rate and they have what they call the periodic rate, right? The periodic rate. So let me come back here. So R in this case is what we can call the periodic rate. Annual rate, right? I think some books will call it a nominal rate. That's what the rate for the whole year. But the periodic rate is what we're looking for now, right? Let me just shift this back. Yeah. The periodic rate is going to be the 4% divided by the number of compounding periods. In this case, there are 4 of them, right? Because the bank is compounding every quarter. So there are 4 compounding periods in the year. So the periodic rate is going to be 1%, right? Your N now is not the number of years. Your N is the number of compounding periods, right? Which is how much years by how much quarter? 4 quarter by 5 years, which is 20, right? So your formula now becomes, okay, A will be equal to 1 million bracket 1 plus, notice 1%, which is, oh, I should say it's equal to 0.01, 0.01, right? So the 20 power. See if you can do that in your calculator. 1.01 to the 20 power, and then multiplied by a million. I'm getting this. 1,220,190.04, roughly. Is that what you're getting?
Yes, sir.
Yeah. I'm trying here to use the same formula. I don't want to give you a new formula, right? So notice the change in the R. The R is not this 4%. This is per annum. But the R in this time is the periodic rate, meaning every quarterly what your interest will be. And the N is not how many years alone, because remember they're compounding this thing 4 times each year. So for the whole year, for the whole 5 years, 20 times they'll compound it. And that's why you'll see some other textbooks. So let me just modify. All right, so you'll see R will be equal to the interest per year over the number of compounding periods per year. And N is going to be equal to the number of compounding periods per year times, what's that? The number of years, right? T. The number of years. Right? So this is interest per annum. This is the number of compounding period, right? Periods per year, right? It's like in this case, quarterly mean 4 times they're going to do it per year. And this part here, right? This again, well, this amount is the same thing here. T is the number of years, right? So you gotta know what the R and the N means when you're dealing with these situations. And that is why if you go in some textbooks, you'll see this, you'll see this. You will see A equal to P bracket 1 plus, and you'll have R over N, right? And then they'll put NT here, right? You see some of that, where the R over the N really is the rate over the number of compounding periods. And you also multiply the number of years by the number of compounding periods, right? So R, you know what P is? R is the rate percent, right? N is the number of compounding periods, right? And T is the number of years, right? But in your calculation, when you do R over N, so let's say the 4% divided by 4, you get 1%. Remember that 1%, you're not putting in 1 inside the formula. 1% is 1 over 100, right? Keep that in mind. So the problem we were dealing with, you will use then A equal, okay, 1 million bracket 1 plus 4 over 4, right? 4%, and you're 4 quarters, right? And then you have 4 times 5. And you end up with the same thing, right? Which is, okay, percent, right? Percent. 1 plus 4 over 4% is really what? 1%, right? To the 20 power, which is, remember 1% is 0.01, right? Oh my God. Equal. And the calculator will give you the same answer. Same answer. It's just the formula looks a little different here. Right? So remember, A, right, is not the interest, it's the amount that accumulates. So now that we have figured out how much would accumulate, the compound interest is really what? It's how much accumulated minus how much you put in the first place. Right? You figure that? So the amount of compound interest that you accumulate will be A minus P. So with the question we were doing, how much was it? For the question that we did. How much we accumulated? 1,200,000 and what? 20,000? Let me see. 1 million.
1,220,190.04.
190.04 minus you put in a million, right? So the answer is going to be 220,000. That's the amount of interest in the 5 years. And in your own time, you can compare that if you were to put it in on the simple interest, right? If you were to invest this money and you were getting simple interest, which one is better, right? Which one is better? You can experiment with that. I think I did give you some notes. I did give you some notes on simple and compound interest. The notes did not involve when the compounding is taking place, like quarterly or half yearly and so, right? Most banks, though, I'll tell you, most banks, you go into the town and you go into a bank and say, how y'all paying interest in this bank? I want to put some money in it. And they'll tell you, they're going to tell you the yearly interest rate. And then they'll tell you that, well, they compound the interest every quarter, most banks. I don't think there is anyone in Guyana that doesn't compound quarterly. Right? But I mean, their interest rate is so small compared to when they lend you money. Oh gosh, their interest rate is double, triple, sometimes 4 times what they give you. You know, like I have a bank that calls me every other day, and they always want to lend me some money. I said, man, I get money in the bank. If I want money, I use my own money. Right? They're paying me interest of like 1%. And they want to charge me an interest rate of 15%. 15 times the amount that they're paying me in interest, they want to charge. You know, banks again rule the world. Banks own all our money. And that's why a lot of rich people, investors, don't use the banks. No, they don't keep their money in the banks. They invest it. Because investments, very often, you do lose on investments, bad investments. But more often than not, an investment would pay you greater dividends than the bank anyway. Right? Good. So let's take a break. Let's take a break and then we come back and we will look at a little bit of, well, we switch topic totally. And we'll talk a little bit more on measurement. Remember we started measurement and we talked about perimeter, we talked about area. So we'll touch briefly on surface area and volume of a few objects. And yeah, we'll try some of that, right? So earlier we had done a little bit of measurement before. Right? We had done some work on measurement. Right? And we talked about the perimeter, right? Distance around, the distance around objects, plane figures, like the square, the rectangle. I think we went as far as the circle, right? Where we talked about the circumference of a circle being 2 pi r or pi d. I'll remember that. We also did some area, right? We talked about area. You know, area of a square, the area of a rectangle. We even talked about the area of the circle, remember? Area equal pi r square, remember that one?
Yes, sir.
We also went a little more complicated, and I think we did this one where you have a circle and you have a sector in the circle. Down here. And you want to find that area, and once you know this angle, you know, let's say that angle is alpha and the radius is r. So the area is going to be, how is it? Pi r squared times theta over 360. Y'all remember that?
Yes, sir.
And the length of the arc around here, let's say this length here, is going to be, let's call it L. L equal 2 pi r times theta over 360. We talked about that. And then we talked about, you have a circle, nice circle. And let's say you have a segment here. This is what you call a segment, this piece here, right? So find that area. Down here, the area here will be equal to the area of the sector, area of sector minus the area of the triangle, right? So you find the area, this whole area. This is the sector, right? And then you find the area of this triangle, right? And then you subtract the two, and then you will get the area of this little piece here. Anybody remember that? All right. Good. So what we want to do, we want to move on to, if you have a three-dimensional object now, right? That's what we want to do. A three-dimensional object. Let's see if I can have a. I'm cutting some stuff from the notes, right? Give me a second. Oh. Look at that. So here we have, well, there's a stone and then there's a cube. Call it a cube. A cube is where all the edges are of the same length, right? These are three-dimensional figures in that they don't cover just a flat surface, right? The cube would have a length, a width, as well as a height, right? I mean, in the case of a cube, they're all equal, but it takes up space now, three-dimensional space. You see, when you talk about, let's say, a square is what we call a two-dimensional figure. It has no thickness, right? It has length, it has width, but no thickness, right? In that square is something you can't hold it, but a cube you can hold it, a stone you can hold it because it's three-dimensional in nature, right? So it might be difficult for us to do measurement when it comes to, you know, a regular stone. But there are formulas that govern objects such as the cube. You'll hear of cuboids, you'll hear of pyramids, you'll hear of cones, you'll hear of cylinders. There are formulas that govern all of them, right? I just wanted to introduce you to them because at the CXC level, you will find that, well, they'll give you all the formulas in like the exam that you have, that paper 2 that you have, right? But it's good to be familiar with them, know what they're talking about, right? Know what they're talking about, right? So let's talk about a few of them, right? And there are two things we're going to talk about these three-dimensional figures. We're going to talk about volume, right? Because they now take up space, right? They take up space. When it comes to area, the area of an object really, it doesn't take up any space. There's no thickness, right? So you find the area of a two-dimensional shape, but a three-dimensional shape would have what we call volume. it will also, let's say this cube here, will have something called surface area. Surface area. In that each of its face will have a certain area, right? Because they all look like, okay, these are squares. And this one has six faces. So sometimes you want to know, what's the surface area, right? And these are valuable things because think about it. If you are manufacturing something, right? You're manufacturing boxes. You want to know how much thing can fit in the box, right? If you're manufacturing the box, you want to know, well, all right, how much material will make up the sides here? So you want the surface area of the box so that you know how much material, how much cardboard you will need to make it. Very valuable information you can get from the volume and the surface area, right? And we'll talk about them, right? So let's start with give me a second. Let's start with the cube, right? For some reason, I've got a lot of mosquitoes where I am right now. Okay, let's start with the cube, right? And the volume of the cube. Maybe I can cut that. Let me cut it somewhere, right? I can't remember if I gave you these notes, but I'm going to send it back. I'll send the whole chapter on measurement. So as you can see there, the volume is L cube, right? So if this is, 4 cm by 4 cm by 4 cm, the volume is going to be 4 cube cm cube, right? Which is 60 by 4, right? (64 cm cube), And it's, this is talking about total surface area. So all the faces are the same, and there are 6 faces. So surface area, the total surface area is going to be 6 multiplied by 4 square, which is what? 96 cm square. Please note the unit. Area is in some unit square, volume is some unit cube, right? Leaving it there so that you can digest the formula a little more. Then there's the cuboid. Sorry, yeah, the cuboid. So it's like an elongated cube. Right? You take the cube and you kind of elongate it a little. So the volume is the length by the breadth by the height. And the total surface area. And here is where I want to warn you. Don't try to memorize formulas. Use some common sense, right? So what the people are doing here, notice they have What do they have? You see, they have 2BH, 2LB, 2LH. They mean, okay, what? BH is this phase here. Now, this over of the thing has another phase just like that. So the area of this phase times 2 will give you this 2. Then they find the area of this side and that side here. And then they find the top and the bottom, right? That's why you're having 2 of everything, 2 of everything. So you're finding the area of each face. And if they have 2 identical faces, you just multiply by 2, right? I look at a simple question. See this one? So they're telling you about, you all know what's a Rubik cube?
No, sir.
You all know what it is? What it is? The Rubik cube. You all don't know that cube where you have like red one side, white one side, yellow, blue, green. That 6-sided thing that you
Yes, sir.
yeah. Right? Call for some amount of I am this age and I don't know what is going on with that cube. Right? You all saw the movie Pursuit of Happiness? Anybody saw it? Nobody saw it? Will Smith? That Rubik,
Yes, sir.
that Rubik cube is what got him the job, and he ended up being a millionaire from homeless to a millionaire. Right? It was very inspiring movies to watch. All right, so let's see. So this is the answer here. So the Rubik cube has 6 cm, right? Each side. Each edge is 6 cm. All right, that's what you see here. So the volume of the Rubik's cube will be, I don't know, this might not be the one we have, right? I think so. I think it's 6, yes. It's 6 little of those cubes, right? And so the volume is 416 cm cube. Now, a little cube, they say how many cube of side 1 cm? If you have a little cube, you know? What's going on? Little cube. You know? And it's 1 cm by 1 cm by 1 cm. So the volume will be 1 cm cube because 1 multiplied by 1 multiplied by 1. So the volume is 1 cm cube. So this whole big cube is 216 cm cube. Then 216 1 cm cube can fit inside, right? Or fill the same size as it. Good. So they talk about a certain cardboard box now. Those are the dimensions. How many Rubik's Cube you could put in this cardboard box? And mind you, these are real types of situations. You know, let's say you're manufacturing Rubik's Cube. So you call up the man who's supplying you the boxes that you will put them in. And he will know what size of box. You can't just make a box and you're packing everything space there in and the Rubik's Cube are bouncing around in there. No. You want a box such that exact numbers of it will fit, right? Good. So here we are, the cardboard box. Yeah. So they give you the dimensions of the cardboard box. You find the volume. It's 12,960 cm cube. But we found out that the little Rubik's Cube will fit or will take up the space of 216 cm cube. So when you divide the big box by the size of one of the cubes, you get 60. So that should tell you, you know what? I can fit 60 Rubik's Cube in this box. Very exact too. I don't want things to be bouncing around. Remember, when you're transporting, if whatever is inside of a box and it's moving around, you ever see how them guys just move things at the airport and stuff? Pelting it all over. They don't care, you know, they don't care. You can't find them to, hey, I see you throwing around my thing. They don't care. So you have to make sure that it fits exact tight. Of course, they have these things where they put bubble wrap and styrofoam and all of that. This screen I'm using here came from the States. I have the box until now. It's right here. I remember when they see that it was a screen, they said, we got to get insurance for this thing, and we don't insure this thing because the likelihood that it will break is so high, we don't want, insure it. They told me they have to get somebody to make a special case to put it in, and so I say, here, send the thing just like that. That thing costs about, I think I paid about $160 something. I told them send the thing just like that. And it came, it was intact, no scratch, no crack, no nothing. Because they packaged the thing so well. Good. And then they have so many other let me talk about this one, the cylinder. Very famous one. The cylinder. Mhm. Right? And you see a lot of objects shaped like this, right? Glasses in your house. The can you all drink Excel and all the other things from shape. Roughly this, right? Roughly looking like that. They have some curves at the edges and so, but yeah. It's roughly a cylinder. So that's the formula for the volume, V equal pi r square h. Basically, it's the surface area of the bottom multiplied by the height, right? That's what it is. That's what would give you the volume. And the total surface area if I'm to break this up somewhat, 2 pi r h plus 2 pi r squared. Now, by the way, this is if the cylinder is closed, top and bottom. Notice it's two circles. Pi r squared is the area of a circle, so that's the bottom. But then there are two of them. That if the cylinder is covered on top, so the top and bottom, the area is going to be the area of two circles, right? Note now what this part is. If there was a label on this cylinder, you cut the label here and you spread it out. So you have a big long rectangle like this, not so? So this is going to be the height. And this curve around here, which is the circumference, 2 pi r, is going to be that length, right? Think about it. If there was a label, a paper label around the cylinder, and you were to make a cut on it and open it out, it would look like a rectangle. And the height of the can will be the h. And that curved paper, when you lay it out, the length here is going to be 2 pi r. So the area of the curve around the cylinder is 2 pi r h. That's where they got this from. Keep in mind that this cylinder, they assume that it's covered on top and bottom, right? Top and bottom. It has a cover there and it has a bottom here. You can have situations where you don't have a top, like an open barrel. You have to find two circles. One of them will be enough, the one at the bottom. Keep that in mind. Good. So let's move this along. This is an example. I don't quite like this example. I'll tell you why in a moment. Look at this here. So you have a cylindrical aluminum container. They give you the diameter, the altitude, and they say 3/5 of its volume has soft drink. How many ice cubes of length 2 cm can be added to fill the space? Right? So you have to find the volume of the one second. Am I hearing rain falling by you now? Yeah, rain starts to fall now. Okay, good. So they found the volume. The volume is just putting the numbers in the formula, right? That's the volume of the cylindrical container. 2/5 of it. Remember, 3/5 is filled with some kind of drink, right? Some kind of drink. So 2/5 is vacant. So we are finding 2/5 of the 8800. So 3,520 cm cube is the space there. So they say, well, all right, how much ice cube you can throw in now so that it will kind of kind of sink in the water, the liquid, and make it fill up the glass. That's what they're telling. Well, the ice cube is 2 cm each side, right? So the volume is going to be 8 cm cube. So how much space? How much will that? How much you need? If you have a space of 3,520 cm cube, and each ice cube is 8 cm cube, well, you just divide to find out how much ice cubes. 440 ice cubes. This got to be a big cylinder. What kind of cylinder is this? Another glass? Or a big cylinder? Y'all follow the calculation though?
Yes, sir.
What? So, maybe I'll cover the cone. Let me touch on the cone. Oh. See if I can find. That's a cone. This is a familiar one, right? And how they came up with the volume of a cone, it's a little beyond us. A little bit of calculus and so involved, right? But they came up with this formula. It's 1/3 pi r squared, which is the circular base. 1/3 times h, right? It's kind of, I should say, intuitive, right? Think about it. It's like, oh, you put another cone here and another cone here, right? It's like 3 cones. So it's almost like a cylinder when you finish it. 1/3 of it. Pi r squared by h. The cone is just 1/3 of like one big cylinder. That's just an intuitive reason I'm giving you why the formula has 1/3 inside. Common sense approach, like, you know. Then there's the sphere, or the ball shaped. Right? The volume is given by 4/3 pi r cubed. The surface area is given by 4 pi r squared. Right? Cool. So what we're gonna do, we're gonna pause there. We're gonna pause. I think you know, it's in one night you can't fill your brain with so many things. Look at these formulas I gave you. I'll send you the chapter on measurement, because I cannot remember how much I sent to you before. I'll send you the entire chapter. You'll get to read it with some examples. And then on Wednesday, we'll finish up on measurement. I think after that, we may have to move on to, what was it? Statistics and probability, and basically our course is finished here. Right? So we'll stop here.